Hey guys, welcome to DevOpsSchool. In this video tutorial, we are going to learn about Kubernetes. Kubernetes is developed by Google and it is an open source platform that automates container operations. It eliminates many of the manual processes involved in deploying and scaling containerized applications. After going through this tutorial, I promise you that the concept and understanding of the Kubernetes will be absolutely clear to you. But before we begin, let me inform you a few things about us. DevOpsSchool is one of the leading platforms which offers DevOps, cloud and containers technology training and certification programs for freshers and established professionals who wish to update and consolidate their skills in the dynamic IT scenario. We ensure that the training solutions are delivered by highly experienced domain experts with practical working experience in various verticals. You can join our all training programs globally through online platforms, and if you're looking for classroom workshop, then we have regular batches available in Hyderabad and Bangalore. Check out the dates and enroll with us for our upcoming batches. For more info, link and contact details are mentioned in the description below.
So today's topic will be Kubernetes, right? So we are going to discuss about Kubernetes, or we call it K8s. Okay, so K is the first letter, S is the last letter, and total letters in between is 8. So that is why we call it Kubernetes or K8s. Okay, so this is basically, what is this first of all? Kubernetes is an orchestration tool. So when we talk about Docker, so it's a container orchestration tool basically. So when we will talk about the Docker, Docker is a container, right? And when we say, if you have say different containers, you have a container for web server, if you have a container for say database server, if you have the container for other application server, and you want that always this is to be up, this your web server is to be up, your database server should take the proper backups, okay, the volumes and the storage part should be taken care. Then who will do that? Because these web server and DB server, they are running as a container. So this is one Docker container, or could be another container type. Okay, this is another Docker. So I will talk about Docker only. Okay. So container itself will not do all this, its maintenance. So container, you can consider it as a virtual machine, but it is not a virtual machine. But if you want to understand the concept, then you can say container is just like your virtual machine. So virtual machine itself cannot manage its resources. For that, we need some extra or some external tool which will take care not about my application, but it will take care about my container. So that management is called orchestration, container orchestration. There are two types of tools we use especially for the Docker. One is Docker Swarm, and Docker Swarm is basically comes along with Docker installation. So if you want to do with a limited functionalities, you don't want to maintain kind of a lot of features. Actually in Docker Swarm it comes with a very limited features, not with lot of features. The reason why that Docker Swarm was invented, because first the Docker was invented, and after that it was a demand that we need to manage the Docker machines. So at that time they have introduced a concept Docker Swarm, but Docker Swarm comes with a very limited features. If you really want to orchestrate your containers, then the best solution is Kubernetes. Kubernetes not only works with the Docker container, it can work with the other container like containerd. And Kubernetes is one of the most demanding tool. If you are a DevOps engineer, you will find that Kubernetes is a kind of a dedicated job. Means if you have done the Kubernetes, and it's very difficult to cover Kubernetes in these 3 hours because Kubernetes is quite huge. It's a very huge topic. It comes with the different types. So, say an example, there is a mini cube. So, if we talk about the Kubernetes, if we talk about the mini cube, then it is basically for the training purpose. So, there is a mini cube. If you work with the AWS machines, means which basically use the AWS services, then you use the kops installation for Kubernetes. If you want to use Google Cloud platform, then you use GCP version of the Kubernetes. If you want to install on the bare metal, so what is the bare metal means? Normal machine, like your virtual machines or physical machines, then you use the kube-ADM. So we will discuss about kube-ADM only. We are not talking about. So Kubernetes comes with the different flavors. So now, if I wind up that what is the introduction of the Kubernetes, it is basically it was the Google product. Google tested it for 10 years and then they contributed to CNCF, which is a uh, cloud-based foundation. And now, because it is tested by Google for 10 years and still Google is using for its orchestration purpose, container orchestration purpose. So you can imagine that how strong or how means this Kubernetes is widely used. All the companies, those who are using containers, it is you can say almost all the companies they are using Kubernetes as the orchestration tool. So some of the Google's product like YouTube, Google search. So these machines or these containers are maintained by the Kubernetes only. So if you see the, I will just share my document. So I will go to my GitHub repository. And this is my Kubernetes. Okay, so this is what I talked. So these are the companies who are using Kubernetes. Earlier it was called as Borg. Now it is Kubernetes. Okay. So now let us talk about the architecture of the Kubernetes. So Kubernetes always work with client server terminology. Anyone has any question, any doubt so far?
All good
Okay.
so far, Raman.
Okay, great. So we have master and worker node. So at least we need one master and one worker node. You can have, you know, master itself as a worker node. That also you can do the configuration. But in real-time scenario, you have master and the worker nodes. So master, when we talk about the master, then it has its own set of components, and the components which is on the client, that is different, or the worker node. So it has the agent or client. Okay, so these components. Okay, so now when we are talking about master, so basically what happens, um, there is a this is master, and this is, so master comes with its own component. The starting component is your API server. So what is this API server? So say an example, if I am running any command related to Kubernetes. So like in Docker, you start the command with the Docker keyword, and then the Docker keyword, and after that you use the command. In Kubernetes, you use kubectl. Okay, in uh, Kubernetes, you use the kubectl. So whenever you are writing a command to fetch some data or to do some activity in the Kubernetes, so first you need to contact to the API server. So what is API? Application Programming Interface Server. So which is basically having the API objects. Okay. So because these days, if you see, everything is microservices, and the communication which happens through the components, that is through the API objects. So API server is the main component by which any action, if you are performing, so that will be triggered through the API server. So if you see this diagram, so in this diagram, if I say this is my master, okay, so this is my master, so this is my cluster basically, and let me change the color. Choose my color. Okay, if this is my master and this is my worker node. Okay, so it basically works on the master and worker node architecture, and this entire thing is called cluster. Okay, this entire thing is called cluster. So whenever we are talking about Docker, we are talking about container, right? So when we say Docker, it means we are talking about container. Whenever we are talking about Kubernetes, we are talking about the pod. So what is pod? In a pod is the atomic unit of Kubernetes, because it has because when we are talking about the Kubernetes, it has more security. So what is the meaning of more security? More security means it is not like your container, which is you can access through your host machine. It creates a separate network for that. So first we create a pod. Inside the pod we put the container, and that pod will have some IP address. And who will provide that IP address to it? It will be the pod network. Okay, so this is the pod network who is giving the IP address. Okay, so this type of architecture. So whenever we are talking about Kubernetes, we are talking about pod all the time. So pod is having container. It can have one container or it can have multiple containers. Okay. So now whenever the master component, so master has the component like API server, master has the component scheduler, master has the component control manager, etcd, and whenever someone is trying to access or trying to connect to this particular master server, they will connect through either GUI graphical user interface, or by using kubectl. Okay, like I have told you that whenever we are writing any Docker command, we start with Docker. And whenever we are writing any command which is related to Kubernetes, we start with the kubectl. So whenever you are writing a command, it comes with the API call. So this is the API call. So this API call goes directly to the API server. So what is API server? In Kubernetes, API server validates and configures the data for the API objects, which includes ports, services, replication controllers, and others. The API services REST operations and provides the front end to the cluster shared state through which all other components interact. So API is basically your REST. So REST is nothing but it's a pattern by which we write the API code. We are not going to write any API code. This is already written, right? So, so what we are saying here, whenever there is a request comes, it comes along with the API request. It goes to the API server. After that, it decides where I need to redirect it, whether I need to send it to scheduler, control manager, or it's a job of etcd. So API server is the main or the starting point by which API call connects. After that, we have the scheduler. So what is the purpose of the scheduler? As I'm talking about the pod. So pod is nothing but it is your atomic unit of your Kubernetes. In the pod, if a pod get created, so basically whenever you are creating the pod, so if you see this diagram, this circle, this indicates pod, and inside the circle you can see this square or rectangle box, that is the container. So whenever you are creating a pod, it get created on the worker node. So how it get created, what are the specifications required? So this everything will be decided by the scheduler. A scheduler watches the newly created pods that have no node assigned. For every pod that the scheduler discovers, and scheduler becomes the responsible for finding the best node for that pod to run. So whenever there is a new pod get created, so it's the duty of the scheduler to find the best node where that pod can run. Next is the control manager. So what this control manager does, whenever we are talking about pod, so pod which has the container inside it, right? Now this pod, what I want a replication. Okay, I put a desired state by saying that at least 3 copies of this pod should run. So pod P1, pod P2, pod P3, and all are running container C1. Okay, so same container is running on these pods. Now what will happen, say an example, this particular, and these are running on single node or multiple nodes. So if it is running on the single node, then it means if it is running on the single node, then if that particular pod is not working or it get crash, then it's a duty of the control manager. Control manager has different component. One of them is the replication controller. So it's a duty of the replication controller to check whether that particular pod has its desired state or not. If it does not have its desired state, then it creates the desired state. So current state is that 2 out of 3 means 2 containers are running out of 3. And I want, so now the replication control, what it does, it will create one more So how frequently it checks? It is infinitely checked. So what is control manager? The Kubernetes control manager is a daemon. The daemon means it's a background process. Embeds the core control loops shipped with the Kubernetes. In the application of robotics and automation, a control loop is non-terminating loop. So who is watching this? A non-terminating loop or infinite loop which is keep watching this. That regulates the state of the system. In Kubernetes, a controller is a control loop that watches the shared state of the cluster throughout the API server and makes the changes, attempting to move the current state towards the desired state. Example of the control state that ships with the Kubernetes today is the replication controller, endpoints controller, namespace controller, service account, etc. Okay, so that is the purpose of the control manager. Now next is the etcd database. So what is etcd, or sometime we call etcd, whatever. So etcd database is basically, it's a database where you store the data in the key value pair, and this data which is stored in this database is confidential data. Okay, so this is a confidential data, means like your username, password, or some sensitive information, so that you can store on the etcd database. So these are the main component of the master. Anyone has any doubt, any question regarding this master component? Okay. Now let us talk about the components of worker node. So when we are talking about worker nodes, so there is one main component which is the kubelet. Okay, so there is a kubelet. So what it does, it takes your port specification. Okay, it takes your port specification. Okay, and one second, guys. One second, give me 1 minute. Yeah. So whenever we are talking about the port specification, so the port is defined by the uh, master component, right? So now ultimately that port is to run on the worker node. So this port is to run on the worker node. So when the port is to run on the worker node, so someone is on the worker node side, it has to take care of that port, right? So now this is the kubelet. So it takes care of the port specification that are provided through various mechanisms, primarily through the API server. and ensure that the containers described in those port specification and running healthy. Kubelet does not manage the containers which are not created by the Kubernetes. So, for example, uh, master has sent one port. Master is saying that on this worker node, I want to run a pod, and that pod is a web server. Okay. And on this worker node, there is another container is running, which is not sent by master. So, say an example, some DB server. Now, the master component or the master who has sent this port, this will be taken care by the kubelet, which is on the worker node. But this DB server, which is created by that machine only, so this will not be taken care by the kubelet. So that's what I'm saying. The kubelet does not manage the containers which were not created by the Kubernetes. Okay, so this is the basically the purpose of the kube. So here you can see this is the kubelet, and it is taking care of the containers which are running in the or created by the master. And there is a kube proxy also. So proxy works the same way as the proxy server does, right? So kube proxy is basically if you want to interact with the external services, or if you want to have the data with the internet, then we use the kube proxy. So this is the overall structure of uh, Kubernetes. Anyone has any doubt, any question?
Can you repeat again about kube proxy?
Okay, kube proxy is basically whenever you want, so this is the worker node. So on worker node, if there is a container or there is a pod, so in that pod, if one second, this guy's 1 second, please. Okay, so in the kube proxy, what happens? So say an example, this is your pod, and this pod is having some container inside it. And whenever you are interacting with the internet, so internet means external world if you want to interact, then you need some proxy server inside the Kubernetes who can help you to move your or expose your website outside the world. So there we use the kube proxy.
Okay, thank you.
Can we have access to these notes? Can we forget?
Sorry, say again.
Can we have access to this your GitHub note? Is it free that we can forget?
You can, yes, you can. I will share with you this document.
Okay.
Let me, so what you can do if you have the GitHub account, so you need to, I will give you this first, and you can open it and you can click on fork.
Yeah, we can forget.
So from there you can basically, it will be automatically comes into your GitHub repository.
Okay, thank you.
Yeah. Now, let me go to the part 2 of Kubernetes. Okay, what is pod? Like in virtual machine, virtualization, virtual machine is the atomic unit. In Docker, container is the atomic unit. Same way in the Kubernetes, we have pod is the atomic unit. So when we talk about pod, so pod can have a container inside it. Most of the time it is one container. So basically what we are going to do, first we need to create a pod network. Okay, and that pod network will have CIDR range. Anybody know what is the meaning of CIDR range? Anyone from the networking side? Okay, so CIDR range is basically list of IP addresses. So if I say 192.168.0.0/16, so it means 16 means everything is 8-bit. This is 8, this is 8. So this is IPv4 example, because 4 octets, 1 octet, second, third, and 4. So if I say /16, it means I can change these two IP addresses, these two numbers, from 0 to 255. So first, we create this pod network. Once the pod network get created, then this pod we can create. And every pod will have some IP address. Okay, so if I'm creating one pod, two pod, so this pod and this pod all are having some IP addresses, which is of this range, 192.168. So we use the pod network, so that is through plugins. So the most popular plugin is Calico. Okay, so we will use this Calico plugin. So now, so these ports are on your pod network, and these ports are containing some containers. Now the pod can have single container or it can have multiple container. So if I say this is pod and this is say my web server and this is my database server. Now each container in the pod should be exposed with some port number. So say an example, this is exposed with port 80 and this is 3306. And if you want to access these container outside the pod, then you need to use the IP address of pod colon the port number. So if I say IP address of pod colon 80, it means I'm pointing to web server. If I say IP address colon 3306, it means I'm pointing to the database server. And if the web server and database, they both want to talk to each other, then they will talk internally with the local host. So if a pod is having only one container inside it, that is called single container. And if it has multiple container, we call it multi-container pod. Okay, so is it clear to everyone? Because our code or our Kubernetes part is totally dependent upon pod. So pod is having container and pod is running on some network which is called the pod network. And pod can have one or more container, but most of the time we are having only one container inside it. Is this point clear to everyone? Anyone has any doubt, any question?
In which scenario, like we'll have multiple ports, sorry, multiple containers in a single pod?
That's what I'm saying. That's a rare case. So, for example, whenever we are talking about say replication or something related to pod, so if you have multiple container inside it, and if you want to perform the similar kind of activity on that containers, so say an example, you want 3 replications. So 3 replications for your web server as well as on the database server. Then you will put it into one pod. And if you want that database server and web server, they can communicate to each other locally also. So in that kind of scenarios, we use the multi containers into a single pod. but most of the time we dedicate a container to a port. All right.
Okay.
Okay. Now, so if you see this, so here I'm talking about the same thing which I just explained you, that there is a web server, there is uh, s- some servers, other container, and they are having their port numbers, and this is the IP address. And if you want to expose these, or if you want to access these machines or containers, you need to use this your IP address colon the port number, IP address colon this 3000 port number, and on port 2, if it has only single container, you can expose this by using IP address colon port number. And when we are talking about the inter-port communication, so it means there will be a port network, and they are talking on the, so if port 1 wants to talk to port 2, then there will be a port network, and on this port network they are communicating to each other. We will have one manifest file. So manifest file is nothing but it's a script file which is written in the YAML, and that file helps us to create the port and create the network, everything. Similar way, if you want to do the intra-port communication, so intra-port communication means master means in one port you have multiple container and they want to talk to each other, then they will talk to each other by using localhost. Okay, and if we talk about the port life cycle, so in the port life cycle we have first pending state, running state, success. So say an example, you are asking to create a port, so initially it will be in the pending state. If it does not create properly, then it will be in the failed state. If it is then it goes, if it is not failed, then it will go into the running state, and if it runs successfully, then it goes into the succeeded state. So this is the port life cycle. And whenever you are creating the port, you basically use the commands, or mostly we use the script. Okay, because handling with the script, it is very easy, and very you can do a lot of things uh, with the port. Means you need to write the YAML file, and in the file you can configure your port, you can specify the configuration, you can put the some container specification as well. So all these things we can do with the help of that YAML file. I will come to that, but before that, let me just first do the installation. So for installation point of view, you need to there are couple of ways you can install Kubernetes, as I explained you, kops, GCP, but we are going to use the kube-adm. Okay, so kube-adm is basically used, it's a generic way to install the Kubernetes on master slave architecture. So here what we are going to do, we will create one master machine, and we can have one or more worker nodes. So I will create only one worker node, and if you want to practice offline, you can create it for the multiple worker nodes. In the master, I will install through kube-adm, and for networking, port networking point of view, I'm going to use the Calico plugin. Okay, so let us see how to install it. So installation is little lengthy. It's not a like in Docker Swarm, it is installed along with the Docker. It's not like that. So what first I will do, I will create my AWS machines first. Okay, so I will create the EC2 instances. Actually, I already have two machines. These two are the puppet machines. I can use this. My puppet and Kubernetes. There should not be a problem. Okay, let me use these machines. These are my puppet machines. So let me connect with my SSH client. Okay, so I think this is 111. Yeah, so 111 is my client. Okay. So I'm using this. These are the Ubuntu machines. So its name is Puppet Master, but you can think, or if you want, let me change it. Host name as KMaster. Okay, so this is my master machine, and same way I will use the other machine, which is okay. So here, this is my Puppet agent. So I will call it sudo su, and I will change the host name. Worker. Okay, so this is my worker node. Now you need to go to the Google, and you need to search for the kube-adm installer. So there is the official website for the Kubernetes from where I'm going to use the steps. So down here, you need to, so you will install the packages on your machine, kube-adm. So these are the packages which get installed. The command to bootstrap the cluster. So this command kube-adm is basically, so there will be a service which is called the kube-adm, and that will be used to bootstrap the cluster. Kubelet, so the component that runs on all the machines, right, in your cluster and does the things like starting the ports and container. So kubelet, we have seen that it's a worker node component, right? And then kubectl, the command line utility to talk to the cluster. So here Ubuntu and Ubuntu machine installation steps. So I will copy it. So first thing is that it will download some of the prerequisites for the Kubernetes. So these are the softwares. So I'm going here, and these commands you need to install on both master as well as on the worker node. Okay. Now second command. So second command is that I'm downloading the package key first, which is the GPG key. So it returns okay, then it is fine. Yeah. Okay. Next, I need to update my repository. Okay, same command on master. Okay, then I need to update my repository. Now we need to install our 3 components, which is kube-adm, kubelet, and kubectl. On master as well as on the slave machine.
kube-adm is the API one.
Kube-adm, yeah, so it's all are API objects only. So this now we need to install the master components. So these components are common to both master and slave. Okay, now we are going to install the master component. So now I don't want that any update come to these services. So that is why I mark it as a hold. Okay, so now my common installation is done. Now next thing what I need to do, I need to install the master component, which has your scheduler and scheduler, control manager, API server, etcd. So that commands I need to execute on the master machine only. So for that, you need to go to the next step. And all the things are inside one command, which is kube-adm init. Okay, so I'm on master. So if I say kube-adm init, then API server. So if you want to read this documentation, you can read it. But this step I need to follow. Equals to the IP address of my IP address. Okay. Yes, I have. Actually, this is. Where is this? Okay, so my master machine IP address, you can use public IP or private IP. So I will prefer to use the private IP address. Okay, then what we will do next, then we need to provide the port network, and the port network you can see down here. There is a Calico network, so you can use the other also, means whatever you want to use, but Calico port network plugin is very popular and widely used in the company level. So I'm also using this Calico, and what you need to do, you need to write this command port network equals to this, copy. You need to. So now what it will do, it will create the IP address of this range, 192.168. 0.0/16. Okay. Okay, so if I say enter, okay, so there are two errors. Actually, we need to install Docker first on both master and client machine. So I will say apt install docker.io -i, because it is a container orchestration tool. So we need to have the container software installed. Same way here, apt install docker.io. Okay, so it is installed. Now if I run the same command again, now it is giving there is one error. It is saying number of CPU. The number of available CPU is 1, which is less than required 2 CPU. So if you need to install Kubernetes with kubeadm, you need at least 2 CPU, because we are using only one that free version of the AWS machine, so it has only one CPU. But we can ignore this error, because this will impact the performance. So it will not impact anything else. So I will ignore this error. So how to ignore? You need to write this: ignore pre-flight errors equals to, and you can say number of CPU. So this I am doing on the master machine only, because it will install the master component. So it will initialize the API server, advertise address equals to your master server IP address and the port network, and then I'm ignoring some of the errors. So let me run it. So now it is doing something. Okay, so now this command runs successfully. So now what I need to do, what it is saying, to start using your cluster, you need to run the following regular user commands. So I need to run these commands. Okay, so let me run this command. Okay, so it basically creates some directory, user directories. And what it is saying, you need to run this command on the worker node to join as a worker node. So the other machine is not a worker node for this. So I'm going to copy this join command and I will run it over here. Okay, so this basically comes with the certificate and the token key. So when I run it on the client machine, so it is saying it is joined, right? So run the kubectl get nodes command on the master to check whether this node gets joined or not. So what I will do, I will go to my master machine and I will run this command. So when I'm running, it is saying See, worker node and the master node both are in my Kubernetes cluster, and both are is not ready state. Why it is not in the ready state? Because we are left with one step of Calico that we need to run, which will run one YAML file. So let me copy this and let me run this. So it will install some extensions. Okay, and if I say kubectl get node, so now you can see still it is in not ready state. So we will wait. So now worker node is in the ready state. Okay, so let's wait. Okay, now both are in the ready state now. So now my cluster is ready, which is having master component on the master node and the worker component on the worker node. So these steps basically I believe I have on my nodes. Let me check it out. Yeah, I think I have that steps. So yeah, so I have noted down these steps here. So you can follow this or you can go to directly to the website. And this, by the way, this is the logo of KubeADM, which is the helm, because it's a Greek word basically. So helmsman or a captain of a ship. So on the basis of that, they have created this. All right. So now we have done the installation. Now let us write the program. Anyone has any question, any doubt so far?
Everything is fine, Raman.
Sorry?
I said everything is fine.
Okay, great. Okay, so now first thing what we need to do, we need to create a pod. So what I'm going to do, I'm going to write a program now, and the purpose of that program will be to create a pod, and in the pod I will create the container, and under container I will run some application. So this will be my structure basically, which I'm going to do. As I told that pod is the atomic unit of your Kubernetes. So let us see how to create the pod. So whenever we are creating YAML file, so YAML is a yet another programming markup language, and which is, if you see in our Ansible, we have used extensively that YAML. So same way here you need to write the code in YAML only. What are the main thing which you need to which you need to take care while writing the program? It can be any program. Means we are starting with the pod, but you will create the replication controller, you will create config maps, secret maps, right? Such kind of okay. So for that, so let's first create the pod. So first thing is the API version. This is important. So whenever you are creating the API version, so it depends what type you are creating, what kind you are creating. So one is API version and second is the kind. So these two are linked. So if you are creating pod, so you will say my kind is pod and version is v1. So for pod, you need to use API version v1. For replication controller, v1. For service V1. So in replication control, it is capital V1. In replica set, it is app/V1. So this is the table that you need to take care while you are writing the code. If you are writing for the pod, you need to use API version V1. Then next is the kind. So kind means what you are going to create, whether you are going to create a pod, whether you are going to create replication controller, service, whatever you are going to create, you need to put kind. Then next is the metadata. So what is metadata? So metadata means about your pod. What will be the name of my pod? If you want to define some properties, then you will use labels, some custom properties. Like here, my app is Nginx, my tier is dev. Okay, so this is called the metadata. Then next is the specification. So specification indicates your container specification. So what is my container for this port? I'm using the container name is this, and container image is Nginx. So it means I'm going to create a container which is inside this port, and this container is having the image Nginx. So it means when I run this port, automatically it will have one container, and in that container we are having the Nginx image. So let us see how to create that. For this, basically what you need to do, I already have the scripts, and these scripts are, let me open separately now. This I don't need, or this I don't need. So let me open my GitHub repository separately. And here you can see Kubernetes demo files. And my scripts are written here. So I'm opening my first ports.txt file. And here I try to write the step by step all the things. So what I'm going to do, I'm going to create a port, and I will create a file which is called nginx port.yaml. Means you can create any name, but I'm just giving nginx port.yaml because I want to create a port which has a container nginx. So now I will go here. For this, what I will do, I will create a directory, which is not a mandatory step, but I'm creating for, so I'm creating this, I'm going inside this. Let me create a directory called whatever the things I'm creating. I'm creating ports. So I will create a directory and I will go inside that directory. And now here I'm going to create a file called nginx port.yaml file. And the code which I have explained you, this is YAML code I'm going to write inside this. Okay, so same thing. Now I will save it. So here, so if you want to see is there any set of ports, so you can see, write the command kubectl get ports. Okay, so it is saying no resource found, means there is no port get created so far. And now we have created our file, which is nginx port.yaml file. For this, if you want to run this file, you need to write the command kubectl create -f and your YAML file name. So now what it has done, it has created one port, which is, it basically runs your script and created the port because the kind was port. So now if I say kubectl get ports, so you can see there is one port is running. 1/1 means one is desired state, one is the current state. So first is the current state, second is the desired state, and it is in the running state. Okay. Now, but where it is running, whether it is running on master machine or on the worker node, so that you can see with the command port -o wide. So now it is saying it is running on the worker node, and this is the IP address. Okay, so if I go to my worker node and Docker is already installed, so if I say kube so if I say here Docker ps command, so you can see there is one nginx is running, right, which was created about a minute ago. Okay, and there is also one port. This is something else, not related to nginx. So this is the nginx which is running, right? And so it means one port get created inside, and that port is running on worker node, and inside that worker node, inside that port we have the nginx running. Okay, so we will explore more, and this is the IP address. This IP address is the IP address of your port. Okay, that you need to understand. So this is the IP address of not of your worker node. Worker node has IP address this 13.233.172.1111. But this is the IP address of that port which has one container inside it. Okay. Now if this particular port is running on this IP address, then if I use curl command, so can anybody tell me what is the use of curl command?
You can test whether you're able to reach. You can make get and post calls. Reachability test
So
kind of.
basically, yeah. So basically it is used to get the HTTP response. So if you say, I want if you want to see the HTTP response, then we use the curl command. So if I say curl 192.168.120.4, port 80 is not required. You need not to write. So if I say 120.4, if you want to write :80, it is up to you. Okay, but that is not required. So if I run this command, so what it will do, it will go to this IP address and go to port 80, and whatever the HTTP response comes, it will display that. So what will be the HTTP response here? My nginx service is running on port 80. So that response should be displayed here. So if I press enter, so you can see there is a welcome to nginx. So this is the default page of your nginx. Okay, so this is the default page of your nginx. So your nginx service is running on port 80, and this is the output. So far, basically what I have done, I have created one port. Under that port, I have created one nginx, and I have seen that in that port, that nginx service is running by using curl command. Now I want to see whether this thing can I access externally also. So if I want to access it outside the port, let us see whether I can access it or not. So for that, I will take this IP address and I will go to where I will go here and I will paste it, port 80. See, it will not give any output because it will say that site is not found or site is not reachable, because this is not exposed to outside the world. So for that, what I need to do, I need to create a service. So port, so basically what I'm trying to say here, I have one port, okay, which is having one container. This is not accessible outside the world. It is not accessible to my browser, right? To access to the browser, I need to use the kube proxy. I need to use this kube proxy. Basically, what I need to create a service. And these services are of two types. One service is cluster IP service and other is node port service. So what is cluster IP service? Which is accessible within the Kubernetes network. That is the cluster IP. Node port, it is for the external world. Means if you want to access it outside the world, then we use the node port. So what it does, it basically create one virtual IP address and one port number. So with the help of that virtual IP address or port number, we can access it. So let us see how to do that. So this is overall, means your port, you are going to connect with the service, and service is of two types, cluster. So we need, if you want to access through the browser, it means you need to create the external service. So let us see
Cluster
how
IP.
to.
So cluster IP is IP as service.
No. Cluster IP is basically a type of a service which is for the internal purpose within the ports. Okay, so if you want to access this website within the ports, then you use the cluster IP type of the service. Cluster IP is the name, it's not IP address basically. So we call it cluster IP. And if you want to use same service outside the cluster, means in the browser, then we need to use the node port. Okay. So let us see how to. So if I'm on the master machine, right, and I have seen with the curl command, I'm able to access it. Now let me go to my notes. So this is get ports and this thing. So now I'm going inside the port. So how to go inside the port? The command is kubectl execute -it your port name --bin sh. Bin sh is nothing but your shell. Okay, so I'm inside the port now with this command. Now what I'm going to do, I'm going to create one HTML file. So I'm creating one HTML file, and where I'm creating under the user share nginx HTML test.html. So this is the path where your websites related to nginx means that web pages are available. So I'm copying this command. I'm creating one HTML page. So this is the HTML page get created. Okay, now if you want to come out of this port, you need to write exit. Now if I say same command, curl this /test.html. So what is the content in the test.html? Testing, congratulations, you are passed. Okay, So port 80 is optional. I'm not writing it. So you can see the same result I am getting. So it means within the cluster I can access it. Now I want to access this website outside the world, means onto my browser. So for that I need to create a service. So how to create a service? kubectl expose port means which you want to expose the port. So this is my port name. Type equals to node port, and this service will listen port number 80. So I will run this command. Okay, so it is saying now service is exposed. So service is exposed, then if I say kubectl get service. So you can see there is a service get created, which is the node port service. For this part, the name of the service is this. And port 80 is configured to 32404. Okay, so this is the virtual port which is provided. So I will copy this. So before copying this, what I will do, I will go here and I will see my master address. Master IP address is this one. So I will copy this column and I will take this 32404. So you can see now I can access Nginx service, and if I say /test.html, so you can see my test.html page is also visible. So this way basically I have created one port, and that port is exposed to outside the world by using node port service. So once you are done, and if you want to delete the services, delete the ports, so the command will be, so the command will be delete the service. So I had given the same name of service and my port, Nginx port, but you can give the different name if you want. So now my port is deleted, my service is deleted. So if I say, kubectl get service, so there should not be a service node port service. And if I say kubectl get ports, so there should not be any port. Okay. So in this example, basically what I have done, I have created the port, I have created a service. Anyone has any doubt, any question?
So the public, how did you get the public IP for the service? Like it was showing
So
some 10.IP only, right?
yeah, so this is the old one. This is not created by me. This is the Kubernetes it has created. So when I created my service, at that time there was a new service get created, and because I have created the node port service, so it got that and I have mapped it to port
Can you
80.
scroll up? I think we have
I will
displayed
write
that.
Okay, yeah.
So
This
here,
one,
like
yeah.
if you see, it's a 10 dot, it's a private IP, right? So how did you attach it to the public one?
Okay, so
The browser
basically
created a public
whenever,
one.
yeah, so basically what happens, whenever you are creating a service, it will create a virtual IP address. So this IP address is your virtual IP address. It's not the real IP address. And this virtual IP address comes with a port number, which connects with your kube proxy and expose your port data outside the world.
Sorry, I didn't get it because if you open the browser, like it's a 13 dot something. So how did we get that
Yeah,
IP? Is
that
it
is my
your system IP?
So if you remember, if you remember that in the kube proxy we have discussed, right?
Mhm.
So now this is running under my Kubernetes, this 10.106.240.87. This is the virtual IP address, which is create when we create the node port service or when we create any service basically. So that service, once it gets created, it creates its own virtual IP address. And the purpose of that virtual IP address to map with the port. So if you see here, I'm saying port 80 should be mapped to this particular port number, and this port number automatically get generated for this IP address. And now this service needs to expose outside the world. For that, I cannot use this IP address because this is within the Kubernetes or within my cluster. To
Yes.
expose to outside the world, I need to use the IP address of my system, my master node. So I have used
Okay.
the IP address of my master node, and where port 80 is configured means I need to expose this port number because here this port on this port number, like your normal web page, it is running on port 80. So what you do, you put your IP address of your master and port 80, right? Same way, now my service is running on this particular port, which is internally connected to a pod, and pod is having one web page running. So when I say my IP address of master colon this port number, then it exposes the port service.
Okay.
Is it clear?
Yeah, it's clear. Like we are using master IP and then it's pointing to service and service is pointing to the actual pod.
Right, right. All right, so what we'll do, let's take a 15 minutes break and then we will see some more uh, configurations or YAML files related to Kubernetes. Okay guys, so I'm back now. So far we have created a pod and a service. Now let us move forward. Now next is to create a configuration map. So what is the meaning of the configuration mapping? Say an example, I have some files on my host machine. So I have file 1.txt file and say file 2.txt file, which has some data, text file. This should be the text file, some data. And this data I want to move to my pod. Okay, from my host machine to pod. Okay, so there are multiple ways. First way is that you can use the config map. So what this config map will do, it is of two types. One is from file and other is from literal. So this is the file, my file 1.txt or 2.txt. So here what I will do, I will use from file and I will say read the content and store it file 1.a or file 1.b. So I'm saying the data of file 1.txt will store into some variable and create the file 1.a and file 1.b for my file 1.txt and file 2.txt respectively. Then I use the from file. And if you want to store the data into the environmental variable, then we use the from literal. Okay, so let us see practically, then you will understand more clearly about this. So what I'm going to do, let me create one more folder here. So I will say mkdir config map. Okay, so let me go to my notes and second is config map.txt. So if you want to see is there any config map already created or not, we use this command kubectl get config map. So let me run this command first, and you will see there is no resource found, means there is no config map is defined. Okay, now let me create one file. So this command will create file1.txt file, and where I am writing non-sensitive data from file 1. Similar way, I am going to create another file which is file2.txt, and here I am writing non-sensitive data from file 2. So if I say cat file1.txt, so this is non-sensitive data from file 1, and same way if I say read the file 2, so this is file 2. Okay, so this data I want to move it to my port. Okay, now first let me create a config map. To create a config map, the command is kubectl create config map, then your config map name. So I'm creating this hyphen volume hyphen from file1.txt from file 2. So it means I'm creating two keys. One is the file1.txt and another is file2.txt, which will have the data related to file 1 and file 2. Okay, so let me run this. Now if I run the command get config map, so you will see there is a config map which is nginx config map volume get created, and it has two data. Two data means one data is for file 1 and other data is for file 2. And age is 6 seconds ago it get created. Now next is I need to move this into some port, right? So for that I need to create the port, right? So now this data is already configured to this variable. How can you see that? So you can run this command kubectl describe config map and your config map name. So if I run this command, so describe command, so here you can see there is a data file1.txt which is having this data, non-sensitive data inside file 1, and I have another key which is file2.txt and it has the data, non-sensitive data inside file 2. Now even though if I remove these files, if I say rm file star dot star, okay, so now you can see I don't have this file, but my data is basically this is get stored into these two variables. Okay, now next I need to create the port because I need to move this data to my port. So for that I need to write some code, right? So let me create a file. You can give any name. I'm giving this name. So if I say vi, and this is the file name, it should have the extension YAML. Name of the file does not matter. Okay, let me just copy it and I will explain you what it is. So here what I'm doing, I'm going to create a port. So kind is port. So API version is v1. Metadata means name of the port is this. Specification of my port is that it is having container, and container is nginx container. Now when you are moving the data, when you are moving the data from your host machine to your pod, it means you need to move it into some folder, and when you are moving to a folder, you need the volume. Okay, so in Kubernetes, we can create the volume by using volumes tag or key. So here volumes, name of my volume is test volume, and this volume is configured to my config map. And what is my config map? This is my config map name, okay, the one which we have created. It has items. The key item, which is file1.txt, which has non-sensitive data for file1, this is to be created at path. It will create this file1.txt. It will create a new file, which is file a.txt, and which has the value, whatever the value we are having for the file1.txt. Similar way, file2.txt data will get copied into the file b.txt. So this is the configuration of my volume. And now this volume I am mentioning here in my container. I am saying it has image this and volume mounts. The name of volume is test volume, which is same as this. And where this file get created, file a.txt or file b.txt, it will get created under the etc non-sensitive data. Okay, so this file is read-only file, right? So if you want to create this volume files is read-only, you just need to write read-only true. Okay, now I will save this and let me run this. So to create command, right, kubectl create -f and your YAML file name. So it will create the port. So if I say kubectl get ports, so you will see there is one port get created. And if you want to go in detail of this, what this port is having, so you need to write kubectl describe port and the port name, which is this. Okay, so here you can see the detail of this. So here you can see this port is running on your worker node. This time it was started. This is the IP address. Nginx container is running, right? And you can see volume. There is a test volume. So every information related to that port you can see with the describe command. Okay, the other thing is which is related to your volume, right? So it is saying a volume is populated by the config map. Okay, which config map? This particular config map. Now, when I run this, when I have created this port, then it should create that. It should create that port, and inside the port that volume should get created, and under that path, the path which we have mentioned, etc non-sensitive data, there should be a file a.txt and file b.txt. So let us see whether that is available or not. For that, what I need to do, I need to go inside my port. And to go inside your port, you have two ways. One way is that, as I have shown you earlier, kubectl execute, and you can directly run this. Other way is that you can use kubectl same command. Instead of going running this bin IT, means you don't want to go with the interactive mode, so you directly run the command. So you can run it direct kubectl execute your port name ls. So I want to run the ls command under this path. So if I execute this, so you can see there are two files, file a.txt and file b.txt on my port in my port. Okay, and if I want to see what is the data for this, So what is the data under file a.txt, right? So instead of ls, I need to write the cat command. So you can see non-sensitive data from file 1. So it means with that particular file, the script which I have written, with the help of that, I am able to move my data from my host machine to my pod or container. Anyone has any doubt, any question? And this is from file. Okay, so actually Kubernetes is little bit means I feel as compared to the other tools, it is little bit different, little bit complicated. But if you understand the specification, how to write the code in the production, basically what in the real-time application, what we do, we have a script related to our pod, related to our config map, or related to our secrets. We just need to make some logical changes. Okay, means we need to change whether I need to, so today I'm working on file 1 or file 2, tomorrow the file path gets changed. So if you are able to write these simple scripts, then the advanced level of scripts will not be difficult for you. But that only needs some practice, because it's a YAML file. You need to take care of the indentation. You need to take care of how to write that particular syntax, especially like API version, the kind, and what are the different keywords available for each and every component of master node. So these things, if you know, it won't be a difficult task. But yes, you need to practice a lot. Like it is same as your Ansible. In Ansible, if you want to write the script, then you need to practice a more. If you practice it, then it will be easy for writing. If you practice 3 or 4, if you create 4 or 5 times a pod, then it will be easy for you to create the other scripts.
Raman, I just missed a portion of your test. My apologies. So
Yeah.
if I say have a database, like a stateful kind of service running, and if I want to keep the database password and user and all these stuff, should I keep that in the secrets or the config mask?
So that you can keep it into the secrets, not in the config map, that is for sure. If you want to keep it into your Kubernetes, if you want to keep it into the Kubernetes world, then it should be the part of the secrets, not the config map. But uh, if you want to keep it there, because the state means, I think you are talking about the sessions, right?
Yes,
Sessions data. Okay.
stateful. Yeah.
So yeah. So for that, the best way is to keep it under the secrets, and we will see in the next example how to keep it into the secret.
Thank you.
Yeah. So this way, basically, I am storing the data from file to file by using config map. How to keep it into the ports. Now there is other ways also that you can create some literals. So literals are nothing but the variables or environmental variables. So what I'm going to do, I'm going to create a config map with environmental variables. So if I say this command, kubectl create config map, this is my config map name, hyphen hyphen from literal now I'm writing. Earlier it was from file. And my literal is file.to. Okay, so my literal is file.1, which is pointing to file.a. Literal is file.2, which is pointing to. So basically what I'm saying, this is my variable and it has value file.a. this is my another variable file.to, which is having the value file.p. Okay, so these are the variables. So I'm creating these variables. Okay, now if I say kube-ctl get config map, so you will see there is another config map get created which has two data, right? And if you want to see what is that two data, so you can see kube-ctl describe config map and the config map name. So I want to see about this. Okay, so okay, describe spelling is wrong. Okay, so you can see there is two data, but here I can see the data. In the case of secret, you cannot see that data. But here I can see my data is file.1, which has value. So key is file.1 and value is this. Second key is file.2 and value is .p. Okay. Now let us create a pod, and in that pod I'm going to refer to some environmental variable. So let me create one file. So this is my pod file which I'm going to create. Okay, here I will write my pod data. So I'm going to create API versions. So if you see here, API version v1 kind pod metadata, this is the name of my pod. This is the container. I'm creating Redis image. You can create any image. Okay, Ubuntu or Nginx. Now I'm creating one environmental variable, and environmental variable is file_1, and the value to this variable is coming from config map reference. And what is the config map reference? Means your config map. So the name of my config map is this, and the key which it has value file.1, this is the key, and it has value file.a. So my file_1 will have the value file.a. Same way I'm creating another environmental variable in my pod, which is file_2, and it will have the key file.2. Okay, so let us run it and see. Okay, now I need to execute this script, and to execute this script, kubectl is okay. So port get created. If say kubectl get ports, so you can see there is one more port get created, right? So it is still in the creating containers. So now it is in the running state. Okay, so now if I say if I say this, and if I say kubectl describe, and if you want to describe the pod, okay, and the pod name, so you will see the information related to this pod. This is the IP address, priority, this, and here down somewhere we will see the variables. Yeah, environmental variable. There is a file1, and the value of this file1 set to the key value of the file.1 in the config map. And same way file_2, which is set to the key value of the. So if I see these environmental variable, they should have the value file.a or file.p. So one way is that you go inside the port, but I'm using the other way. So if I run this command, so I'm going inside the port, and if I say environment, so it will show the environmental variable. So, and here you can see there is a file underscore one, which has value file.a, and file underscore two, which has value file.b. So this way, basically, I'm going to use these keys as the environmental variables. All right. So this is from literals. So now let us do the cleanup. We'll delete all config maps. And we will delete the ports as well. So both the ports I'm deleting. Okay, and then you can cross verify by writing kubectl get ports command to check whether that port is still there or not. Okay, that you can do yourself. So now next topic is the secrets. So secrets and config map both are same. Okay, so secrets and config map both are same. The only difference is that secrets data is you cannot see, while transition you cannot see that data. So when you are transitioning from your host machine to your pod, you cannot see that data. Here you have noticed that when I used file 1.txt, I can see the data. It is non-sensitive data, but here you cannot see. So let us see that how to do that. So for that, let me create a directory, say secrets. Okay. So secret also comes with the from file and from literal. So let me create that. So let me create a file which has the username admin and password in the password.txt. So I'm creating two files. Okay. So if I say cat username.txt, so you can see it has admin inside it. Same way if I say cat passwords, and it has the password. Okay, so my motive is that I need to move this data from my machine to host machine, but during the transition there should not be any means my data should not be visible to in between during the transition. So let us see how to achieve that. So then I'm writing this command. So when I run this command, kubectl create secret generic, and this is the secret name from file username.txt and from file password.txt. So what it will do, it will create a database, or in the database it will create one entry which indicates from file, and it has the key as the username.txt, and the value is whatever the text inside it. Same way it will create another uh, key which is password.txt, and it has that file. So let us see how it will do. So secret get created, and if you want to see kubectl get secrets. Okay, so there is already one secret get created, and this is the another secret which I have created just now, and it is having two data. So if I say kubectl describe secret and the secret name, which is this. So you can see now the data key values is appeared, but the data is, you cannot see. It is just saying 9 byte data or 5 byte data, but it is not showing the data. So this is basically opaque type. Opaque means it is, you can say, encrypted data, right? Now, if I want to move this data, now I cannot see the data, whether this data can be stored somewhere. So if it is stored, then I can move this data to my pod. So let us create a pod and move this data. So for that, what I will do, I will create one pod. So how to create that pod? You can run, I will create this file, the CML file. And in this CML file, I'm going to create a pod. So now we are repeatedly doing this kind of work. So I think now you may understand what I'm writing. So kind this, metadata is this, container specification is this. I'm creating a volume, test volume, and here I'm using secret. Okay, and this secret means it will store the secret, and my secret name is nginx volume. Okay, so what it will do, it will take this volume data, my secret data, and I want to copy it to my volume mount. So my volume mount is test volume, which is the same name as this, and path is this one. So it will take that data and it will copy it to this particular folder. Okay, and it is in the read-only mode. So now what I would like to do, I want to run this file. Okay, so this get created. Now if I say kubectl get ports, so you can see there is one port, and if I say kubectl describe port and the port name, okay, and here you can see this is the volume running on worker node. This is the IP address, and here is the volume test volume, and this is the mount, right? And test volume, you can see here type is the secret and the secret name. That's it. So it will not reveal the data. So now if I go inside my pod and I want to see what is inside it, so you can do in this way. You can go inside it, or you can directly go to the kubectl execute your pod name ls confidential. So I will go into this folder, and you will see there is a password.txt and there is a username.txt. And now I want to read that data. It should be the same as we have on my local system. So I'm reading the username.txt. You can see it has the admin. And same way, if I want to read password.txt, so it will have the password information. Okay, so this way your data from the file, it is getting moved to the the ports machine. Anyone has any doubt, any question? Okay, So now this is the from file. So if you want to move the data from your variables or literals, as we were doing in the config map, so we can do that also. But when you are using the literals, so literals are having some values. So I need to encrypt the data. Okay, before moving, I need to encrypt the data. So that encryption, for that we use some algorithms. So like base 64 algorithm, right? Or your so mostly we use the base 64 algorithm for this, which encrypt my data before moving it uh, to the port. So let us see how to do that. So for that, I'm creating. So I'm again creating one variable. I'm not creating a variable. I'm just showing you that if I run this command, so admin, if I use base 64 algorithm, so what will be the value? So value will be this. So this is the encrypted value of my admin world. Okay. Same way, if you want to see the encrypted value of your password, if you write this in the base 64, so this is the encrypted value of the password. So I will use these value to move the data so that it will be in the encrypted mode. So what I'm doing here, I'm going to create a port, not port, I'm going to create a secret first. So here you can see my API version is v1, kind is secret, metadata is name of my secret is secret. So I'm creating some variables. So there I have used hyphen from literal keyword, but here you need to create a YAML file for your secret literals. So here I'm saying my data is username, and username is this value. And what is this value? This is the encrypted value of my admin. And the password is having this value, which is the encrypted value of my password. Okay, so let me create this secret first. So if I go here and if I say I want to create that file, and in this file I'm going to create these two variables. And if I say kubectl create, so create command is to create this whatever the kind you want to create. Okay, so this get created. Now if I say get secrets, so you can see there is one more secret get created. This is the one. And if you describe this secret, then you will see there are two variables. One is password, one is username, but you cannot see the value what is inside it. Now we need to consume this secret, so I will create one port. So to create a port, I am creating one YAML file. Okay, so I will copy that content. Okay, so here you can see version, port, name of the port, container, environment. I am creating secret username, which will be pointing to the secret reference key, and the key is username. So it means environmental variable secret underscore username will have the value whatever the variable username is having. Same way, secret password, which will have the value which is from the key password. Okay. So let us save it, and now let's run it. Okay, so this get created. Now if I describe my port, so there is a secret username and secret password, and this is right. So username and password. Now let me go inside the port and let me grab the environmental variables. So I'm going inside that port and environment variables I want to check. So here you can see username, the value is admin, and the password, which has value password. So this way I'm just using my confidential information into my secrets. Anyone has any doubt, any question?
Huh?
Okay. Yeah. Okay. So now let's move to the next topic, which is, I believe, next topic is deployment. So config maps, secrets, replication. Okay. So next topic is replication. So replication is nothing but, so let me create a directory for the replication controller, actually it is. So what is the meaning of replication here? So say an example, you have a port and you want to create 3 copies of this. Then I will use the replication controller. So replication controller take your port, you need to give the desired state. It will keep monitoring your current state and make it to the desired state. So in case if a particular node get crash, okay, so then it will automatically monitor it and create a new pod on your worker node. So whatever the worker node it finds suitable for that, it will create that worker on that worker node. So on top of that, you can scale up. Scale up means if you want to increase the replication, the number of if it is 3 now, and you want to do it, make it 5, you can scale up. You can also scale down whenever you want. So say an example, currently the desired state is 5, but you want to make it 2. So then it is called the scale down. Okay. So in that case, my kind will be replication controller. So let us see how to achieve this. So for that, I will go to my replication controller.txt file. So I'm creating one replication controller. Here I'm defining the specification. There are 3 replication means I need to create 3 replicas, and within this replication, I want to create a pod as well. So if you want to define any specification uh, for replication control, you need to define the template. Under the template, you need to define your pod. So I'm saying under the template, my pod is Nginx pod. It has label Nginx app. So what is the purpose of label? Label is mostly used for the condition point of view. For example, if you are saying that uh, I want this replication is to be applied on all the ports which has label app equals to Nginx app. So then labels will be helpful. So if I'm creating multiple ports and if I want to create a common category for that, then I will use the labels. So with the help of labels, I can identify it. Guys, give me 1 second. I'll come back. Yeah. So the labels are basically used for that purpose. If you want to create a category of your ports, and for conditional purpose also, wherever you are using the selections. So if you see here selector app equals to Nginx app. So I'm saying that whenever I am doing a selection in the sense means if you want to create the replication for multiple ports, means different types of ports. So you can define the selector here. So I'm saying the selection or the condition is on the basis of whatever I'm writing here. Okay. So let us create a replication controller. So I'm going to create a file which is nginx rc.yaml file. Okay. And I'm going to run this. Okay. So this is the code. Let me save it. And let me run the create command to run this. Okay, so it will create the replication controller and it will create three replicas of my ports. So if I say kubectl get ports, so you can see there are three replicas are running. Okay, still there are some are, so we have created three, right? Yeah, three. So if you see, so okay, we did not delete the previous one, these two, that's why it is showing here. So let me remove this. So I will say kubectl and delete port and the port name. Okay, same way I will delete the another port which I have created for the secret purpose. Okay, so now if I run the command, get ports, now see there are three ports are running, right? And where it is running, that you can see -o wide. So all are running on the worker nodes. So all your ports are mostly, it runs on the worker nodes only. Okay. Now if you delete any one of this port, so let me delete a port. So I'm going to delete this 7F9, right? So if I say kubectl delete port and the port name, so it will delete this port. Now let us see what will happen here. So if I run this command again, see, one is terminated, the one which we have. Now it has created a new one. Okay, it has created a new one, which was created 6 seconds ago. And the IP address also you can see it was having .10, now it is having .12. So replication is getting maintained whenever you are creating the replication controller. Okay, now what I want to do, I want to scale up my cluster. I want to create 5 replications. So for that, I will use scale up, means scale replication controller, your replication controller name, and the replicas equals to 5. So now it will scale up basically. So if you see this, now 5 containers are running. So some are under the container creating state. So now you can see 5 containers are running, right? So similar way, if I want to degrade or scale down, so you need to simply write this equals to, if I say 3. So now it is scaled down. So if I go to the ports, so you can see one is terminating, right? Other 3 are in the running state. And where it is running? It is running on the worker nodes. So if you have multiple worker nodes, so it will distribute your traffic accordingly. Okay, so if I see now, there are 3 are running and 3 are running on the worker nodes. So this way, basically, we are creating the replication controller. And now if I want to clean up my the things which I have created. Anyone has any doubt, any question on this replication controller? Okay, so here I'm deleting that my replication controller, and it will delete because it's a part. So this, when I run the delete command, so it will delete everything, replication controller as well as my container. So if I say kubectl get ports, so you will see nothing is found because I have deleted this. Okay, now let us see the next topic, which is the replication set. So replication controller and replication set both are same. So replication controller is same as your replication set. So replication set is called the next generation of replication controller. Here, the difference between replication controller and replication set, the purpose of both is same. Okay, but you can say it's a new version. Okay, or the next generation of the replication controller. What it does, it basically, when you write the code is set based. What is the meaning of set based? So if you want to see the replication control, you use the equality operator. So if I say I want to do a selection where app label means app equals to or colon and the label name. So let me show you with the example. see here. Replication controller is equality based and replication set is set based. I use the operator like equal to, double equals to, or not equals to. And here in the set based, I'm using the operators in, not in, exist. Okay, so say an example, if you are saying environment equals to production. Here I will write something like this: environment in production or quality assurance. Means I can do a comparison with the multiple values. Tier not equals to front end. And here I'm saying tier not in front end back end. Command line, so we can write the in the replication controller. If I write environment colon production, here I need to write match expression key environment operator in values. So only the way of writing the code is different. Otherwise, it is doing the same job as the replication controller is doing. Okay, so let us see in the demo how to do that. So so this is replication controller. So if I go to replication set, okay, so what I will do, I will come out of this. I will create a directory for replication set. Okay, and I will create a file, and the file name I'm giving nginx replication set.yaml file. And here, let me copy it and then we will see what the code it is. So you can see kind is replica set, and the version now you can see I'm writing apps.v1. So if you refer to the table which I have shown you earlier, so for the replication set it is apps/v1. Name of replication set is this replica 3. I'm creating this port. This is my label. The only change you will find here, selector. So there I was writing only the selector app colon nginx app, but here I'm saying match labels. Match expressions means this label should be matched if it is in the key value is the tier and tier in front end. Okay, so there are one is the match label and second is the expression which I want to match, means tier in front end. So tier will be the variable name and it will have the value front end. Let me save this. And now let me run this. So to run this, create command we will use. Okay, so replication set get created, and if you see your port, so 3 replica sets. So if I say kubectl get port minus o wide, so you can see there are three replicas are running. Same command you can use for scale up and scale down. So I would suggest that you can try that yourself. It is same as we have done for the replication controller. And if you want to delete this, so you can delete with the help of delete command. And when you are going to delete it, you will, if you see, these all are getting terminated. Okay, so this is the replication set. Now let us talk about one more topic, which is deployment. So mkdir deployment. So deployment is So when we are talking about the deployment, so what is the purpose of the deployment? Deployment is again deployment of your pod only. So whenever you are deploying the pod, so say an example, I have one pod and it has one container, and container is having one image, and that image is say Nginx image, and that is 1.7 version. Now I want to do the update. I want to update this image, but say an example, there are 3 replicas are running. Okay, and all these replicas 1.7 images running. Now if I upgrade to say 1.9, then what will happen? First, what it will do, it will take only one, it reserve one node, and it will upgrade to this. And the client who is accessing my website, if he is accessing this, it will be automatically redirect to the other worker node for the timing. Meanwhile, it get updated. So now 1.7 to 1.9. So if it is successful, then it will upgrade. It will upgrade this version, as well as one by one it will upgrade the other versions. So now the client can see the latest version. Whereas if this get failed, then it will not going to upgrade the other version, because on other nodes this update is not successful or failed, so this will not get updated to others. So client will see the correct output all the time. So let us see how to do that. So deployment is mostly used for the rolling updates. So I will create a file. So file name is this one. Let me copy this. Okay, so kind is deployment. 3 replicas I want to create, because whenever we are talking about replica, whenever we are talking about deployment, replica will be definitely come into the picture. And container Nginx, and this is the Nginx image. Okay, so let me save this and let me create this. Okay, if I say kube get ports, so 3 replicas, 3 are running. Okay, so now what I'm doing, I'm going to rolling the update, and this version of Nginx does not exist. So let us see what it will do, because it's a failed 1.9.1 it is. So it is saying image is updated, but if I see the status of my rolling update, so you will see it is waiting, and it is trying to finish on 1 out of 3. Okay, it is not updating on all the 3. Okay, now if I want to see the history, what is happening basically, so I can use the history command, and it is saying nothing, there is no change happened. So this command run, after that none, after this command there is nothing happened, whereas I was expecting that it should update my Nginx image version. But here now if I want to undo my update, so I can do that. kubectl rollout undo and your deployment. Okay, so it is undo now, and if you see the status, Okay, so it is saying rolled out. And if I want to see the image, so you can use the describe command. In the describe, I'm searching for the image. Grep -i image. So it is saying 1.7.9. Now let me update with the proper image, which has a valid image number. So if I say this, now it is upgrading. And if you see rollout status, okay, so it is finishing 1 out of 3, 1 out of 3, 2 out of 3. So now it is successfully updated all the, and for the old one is already updated, right? Now what I will do actually, so this is what actually I want to achieve. After that, if you want to Replica 5 or 3, it will upgrade with the newer version of the image. That is what this deployment does. And if you want to clean up, you just need to run the delete command. Okay, so anyone has any doubt, any question in the deployment? Okay. I think I can cover one more topic, which is daemon set. So what is daemon set? So daemon set is basically, so when we are talking about the daemon set, so what it does, it basically, it will have one port. So it has the port specification. Okay. And I want, whenever there is a new node connected to your, whenever your node connected to your cluster, that particular port should be installed on it. Okay. If there is a new node get connected, then this port is to be installed over there. Or some specific, on the basis of some condition. Then we use the daemon set. Okay. So let us see practically. So what I will do, I will create okay, and here I will create one YAML file. And I will copy this code. Okay, so what I'm doing, kind is daemon set, and the name of daemon set is this. I'm using the metadata. Container is fluentd, and this is the image which I want to download online. And label, I'm creating the name equals to fluentd. So let me save this. Now I will create this. So kubectl create -f. Okay, so daemon set will get created. Now we will see the port which I have specified, whether it get created on my, if I say, so it should be automatically get created on my worker node. So only one is getting created. Okay, so if you connect one more, it is same like means antivirus. So if you want that a particular antivirus is to be copied to each and every machine, so you will create a daemon set for that. So you will create one port which is basically running the uh, antivirus, and you can configure it for the daemon set. Okay, so if I see here, now it is in the running state, right? And it is running on this, and this is the IP address for this. And this IP address only means you can get this for the port once it is in the running state. If it is if you see container creating state, at that time there was no IP address. Okay, so this way we are basically creating the daemon set. All right, so that's it for the Kubernetes. As I told you, Kubernetes is ocean, and this is basically means I tried to cover most of the topic, but when you go with the enterprise, COPS, AWS version, GCP version, most of the commands are same, but there you will find some different stuff. So this kind of programming you will find generic programming which you can use for in all the platforms, whether it is AWS, GCP, or bare metal, or Minikube. So anyone has any doubt, any question?
I mean, can you just drop your number?
Sorry?
Can we have your email ID?
Yeah, so for that you need to contact to that DevOps school.
Okay.
So they will definitely because they don't allow me to share my phone number and the email ID.
Okay, fine. Thank you.
Shaka, how can we get this video? Because we once need to watch it at the time.
Okay, so there is some disturbance. I'm not able to hear you.
How can we get this video to watch it again? Because
so that recording you will get it. So you can contact to the DevOps school support team. So this is get recorded. Not only this, whatever the classes you have attended, so all the videos will be there.
Okay.
So you can contact to the Mantosh or the DevOps team, DevOps school team. And my GitHub repository I have shared with you. So you can download the code which I was writing. Everything is over there. Okay.
Thank you.
Yeah. So
Thank you for the session. It was good.
Yeah. Yeah. Thanks.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Want to study further? Subscribe to our paid membership to get a deep dive into each and every topic. Do look out for more videos in our playlist and subscribe to our DevOps School channel and hit the bell icon to learn more. Keep learning.